Hello everyone, today we're going to talk about the second part of our molecular visualization tutorial. Our topic for today is going to be VMD, or Visual Molecular Dynamics. Allow me to just share my screen with you and we will get started. So here we go. You can feel free to follow along if you wish using the slideshow that should be available to you on our Moodle site. All right, so last time we talked about how to download things from the PDB, and we talked about using our first molecular visualization software, Primal, and today we will follow up with the second one. So if you don't already have VMD available, you can download it from this website, uic.edu. And this is called Schulten's Lab, and it's designed to visualize molecular dynamic simulations, but you can also visualize PDB structures with this. And it has a very nice suite of tools in order to generate some very fancy figures. It has a lot of options for materials that aren't available in Primal, so you may find this to be interesting and useful. It can also do a series of calculations for you as well. We don't have time to get into that today, but you'll be able to see that there's a variety of ones that are already built in that you can access through the menus, and also you can download and install plugins if those become interesting to you. So the first thing you need to do in order to visualize something in VMD is to actually get a structure. So you would do this the same way that we did the last time we covered getting a structure from the PDB. And you can save that to your local computer. You could also work with a structure you have yourself, like maybe you're doing some molecular modeling or so forth, anything that's in a PDB file format, but you may typically be downloading those from the PDB. Next thing you'll do is you'll click on the VMD link from your desktop. So here's what it looks like on mine, and it will launch something that looks like this. Notice that there are 3 windows that are loaded here. The main one is the molecular viewer, which is this big one on top, and you'll see this VMD and these axes here. You also have the console, which is going to be a place where you can type commands if you choose to learn more advanced commands in VMD, and also it will be telling you some output as the program is running, basically where the log information is displaying. And the third one is the VMD main, and so when you're using it in the graphics mode, which is mainly what we focus on today, this will be driven by things that you pull down from the menus off of this main menu. Okay, so if you want to open a molecule, you're going to, from main, click on new molecule, and you'll get this window, and it will give you the option to browse for molecules. So you want to have this set for new molecule, and then what you're going to do is you're going to browse for the coordinates for that molecule, wherever your PDB file is stored. This will be a type PDB, so this should come up automatically, but if it doesn't, or let's say you saved it and it happens to be .txt or whatever, you can tell VMD that this is going to be a PDB file, so you can force it to try to read it in PDB format by changing this to PDB. And so since this is a PDB file, this will just be left to the default. So basically you have one frame, and then you just click on the load button. You can use your mouse to move the molecule. To some extent, this may be mapped differently on your particular computer. So it's really meant to be used with a mouse with the buttons on it. But if you have just one of those pads on your laptop, then that also generally can work just fine. You may need to experiment a little bit with how exactly they're mapped on your computer. So I've given you the typical setup, but if for whatever reason they're not working, what you can do is so start by using your mouse to try to roll the molecule around. That's the default thing it's going to do, right click. To rotate about an axis, you're going to left click or middle click, and zoom is press and roll the middle wheel. So if you're not working with a mouse, then those are going to be mapped to your trackpad. And so what you should check is how exactly they're mapped. So the best thing to do is just experiment. So typically to switch between the modes, it's going to be worked by doing the same clicking, but you may need to use Control or Alt or Shift would be the things to try. in order to see how it's mapped to your particular system. So you can also manipulate the molecules using some keystrokes. So there's a variety of different modes you can be in. And so you can get to that functionality using those keystrokes. The things that you would want to be most familiar with is R, S, and T. So that's going to be R for rotate, which is the default mode that you're in already. S is for scale, that means zooming. And T is for translate, to take the molecule and move it around on the screen without rotating it. There's some additional keystrokes that also you may find useful. And these ones you can access also from the main menu. So 0 will select an atom, 1 will turn labeling on for the atoms, 2 labels and measures distances, 3 labels and measures angles, 4 labels and measures dihedral angles. So you can see that it's moving up in level of complexity based on which number you press. And 7 you can use to select a whole chain and drag it independently of the rest of the molecule. This can be useful if you need to do some kind of modeling or something like that, where you're trying to set something up, or if you're trying to reorient some things. Useful tool to be able to use. Graphical representation to render the molecule. So if you select the graphical representations from the VMD main, graphics, and then representations, you'll get this window here. This allows you to change how the molecule is viewed, and is similar to the menus we looked at last time for the alternate way to view molecules. So what we're going to have here is you're going to select a molecule. So it is possible to load more than one PDB file, I'll mention. And the way you will tell them apart is you can, in fact, use this arrow to select other ones if you have more than one available. So you have to think of this in terms of being additive to what's here. So the default will have line selected, that's the wireframe, and it's going to have, it's going to be colored by name, and everything is selected. So you see that there are basically going to be 3 fields for each representation that you make, and you'll just create another representation and then edit it. Okay, so the way you make a new representation is you select a representation that's the closest. So in this case, we only have one representation, and then you click create representation. So you'll be practicing with this in the tutorial itself. And you see that the selection, so here is where the selection is being reported. This here is where you can make a selection. Okay, so you can type something here. You can also use this selections tab to use point and click, and it will allow you to point and click to particular atoms or residues or make selections by various means. Okay, the next thing is the style. So this right here is reporting on the style. So the options for the styles can be accessed through this pull down menu. Then if there are additional things that you can change for a particular selected style, you can use whatever pops up down here. So lines can be changed in terms of the thickness of the lines. And so you can make the lines get bigger or smaller by clicking. So clicking by small will increase it by a smaller increment, and large will do a bigger increment. This down here is going to change whether or not the changes will apply automatically, or whether you would make a bunch of changes and then apply them after you've made those selections. I definitely recommend using apply changes automatically, so you'll see your changes as you go. And I don't really see a reason not to do that. The only time I can think of that you may want to not do that is if your molecule is especially large, or you have limiting resources on your computer and your computer is having a difficult time keeping up. You may wish to make a whole bunch of selections and then apply the changes by clicking on the apply button manually, and then they will all update all at once. So this is how we can create the representation. I was mentioning this a little bit before. So you're going to click on this. So you select a representation that's similar. You click create a representation. And so here we're going to have this representation here. And now what we're going to be doing is we're going to be editing this. So you see that we've selected by the keyword nucleic. And so what this will do is it's going to select just the nucleic acids in our particular molecule. The same coordinates can be part of multiple representations. The representation that you're actually going to see is whichever one is the largest or on the outer surface, unless of course you select some of these opacity changes, so you can actually make things see-through. So you could represent, for example, the van der Waals surface of a particular residue and a wireframe version of the residue, and you would be able to see both of them. You can use an existing representation to start in order to make the next representation that you want to make. You can also double click on a representation to hide it. So if you are working along and maybe you want to, render a figure and then you want to turn something on and render another figure, that can be a really useful thing. So here's some examples of what can be done. So notice that this one up on the top is red. So this representation has been double clicked, so it's turned off, and we notice we don't see the wireframes anymore. This is licorice, is of these thick wireframe version here. It's like a stick representation is how that's called. And you see that the nucleic acids are being selected and it's colored by name. This means basically being colored by the elements. So the typical CPK coloring where oxygens are red and carbons are this cyan color and so forth. There are no hydrogens in crystal structures, which is why we don't see any white, but you can use that representation to identify the atoms using their colors that you're used to from standard chemistry. And we have some new cartoon. That's the representation that's being shown here for the protein. And this has been selected by chain. And you see that there are two representations that are both going to cover chain A. And of course, we don't see both of them because, first of all, they're both in the new cartoon, so they look the same. But you see, you could take this and update it like this. And then if I change the color ID to something else, okay, so what's happened here is we've changed in the draw style, we've selected the color ID to 10, which is the cyan, which you can change the color ID to some other number, and it will display it in a different color, so then you could differentiate the different chains if you wanted to do that, and that's how you would do that. Okay, so suppose you want to select and display some features of a molecule. So notice here that this happens to be the p53 protein, and what we're looking at here is it's binding to a cognate DNA as a transcription factor. And these are some of the residues that are along the interaction interface that are going to be interfacing with it. So you may have a similar situation where you want to select some particular residues of interest. And so this is showing you how that could be done. So you'll see that what we have here is we've changed this representation to CPK coloring style. Again, so each atom will have a different color, and it's going to be colored by element. And then we're selecting specific residues. So Res ID will allow you to select the position numbers as you know them from the PDB file so that you can display those. So they're being now shown in the CPK drawing method, which is the balls and sticks. There's also many more selection menus, and I would definitely encourage you to go through these and see all of the different ones. Basically, they're very discoverable in pull-down menus. So you see here, we're illustrating the use of the selections tabs. So you can see there are some keywords that may be useful, all non-backbone side chain protein, and there are more than that. And then you can also pull out these keywords. So when you pick a certain keyword in this box over here, then over in the values, the appropriate things that could be selected will pop up. So by doing things by residue name, you see that it's showing the residues that are available to select. So you can use these by double clicking on them, and they will take them and put them up here in this box. Once you get a little bit more familiar with them, if you don't wish to go through the menus, you can also, in fact, just type it in directly yourself. You can also control the background color. This is particularly useful because oftentimes we want to have a darker background for projection. So if we're using in slideshows and the like, and when you're going to publish a paper, usually a white background is the preferred version of it. So when you're using VMD to start with, it's going to have the dark background. So when you're working on your computer, it's not too bright. And that's not what you want if you're going to make a publication quality figure, because you'll probably want the white. So you go to VMD main graphics colors. Okay, and so here we find ourselves in the color control. So what you're going to do is you're going to select the category display, and then under names, you're going to pick background, and then you can pick white. There's also many other things you could pick, where you're allowed to pick some other colors if you wish. And also I'd mentioned that there are some color controls here. So if you want to do something like define your own colors, you can do that, and you can adjust here what the definition is of those particular colors. You can also use the movie generator to make movies in VMD. So for example, here what we've done is we've gone to VMD extensions, visualizations, movie maker, and that brings up this dialog that will help you make a movie. So here we set our working directory. This is set to the E drive. This is the name of the movies right now. It's set to untitled. You can type in your own name. Okay, and the rotation angle is set. Trajectories, step size will be 1. And then since there is in fact only one frame, because we only have one PDB loaded, the duration of the movie will be 0 seconds. And that's how you would make your movie. If you had loaded in a trajectory which had multiple snapshots in it, then you would have a longer movie to make. These are some example parameters on how to make a movie. So you may actually choose to put in a name. Here is a rotation angle that's changed from the 180. The step size probably should really stay at 1 anyways. And you see that this one has been set to be 5 seconds long. And so then what will happen is when you click on the make movie, it will start to render your movie. And you see that it's generating different frames for the movie down here. So you're going to see this in the console. And then when you're done, you will see this note here, the movie generation is complete. Once you've done that, then the next thing you'll need to do is you'll need to go and search for your movie. So it will be whatever you had set. So I happen to set mine to an external disk drive E. By default, yours is probably your local disk, or maybe in I don't know, could be in your desktop or and so forth. So you just, if you've forgotten, you just look here, right? So it's in set working directory, and that's where it's going to end up. And so here is my movie clip. So here's my P53 rotate Y-axis movie, and my other untitled movie right here. So then when you're ready to watch it, what you're going to do is you're going to double click to watch the movie in your default player. And since we had set that the rotation, right, this is what it's doing. It's actually going to rotate the molecule for you. So what you're going to do in today's tutorial portion of the workshop is the following. Become familiar with the protein data bank, so you've already worked on that. You've already had a look at the PyMol portion of this in the last section. And then in the VMD, what you're going to work on is doing the rendering again, but using this version instead. Record a molecular movie, create views with various materials, including glass and metal. That's really fun because you can make your molecule look really nice. Then you can render the molecular surfaces and color structure according to the B factor, which could be a useful thing to do. So I hope you have found these information to be helpful for your research and also for other things that you may wish to learn. Please have a look at our tutorial, and good luck. Thank you very much. Bye-bye.